to choose the local for the series. You have your series open?
Yes. I'm not like it.
Yeah, this is it. Can we go to map? I don't know. That's images. That's map. Come on, Yusuf.
You.
Put the need for speed away.
That's this.
No.
Oh, I haven't finished now. To read it.
Who's doing the questions?
I just need to fix them.
Yeah.
Which one?
I don't speak Vietnamese.
But it had the first one.
You can ask. Look.
If you are lucky and you remember the else, you will tell me. But he is still not sure because it's just his memory.
Look deep down in your heart.
You have all of those?
It doesn't have this.
All?
Well, I don't know. I'll have to look at the computer. I can't use your phone. You're great. I don't remember. I'm sorry. Just like Wong, I don't remember. But I think it was a B.
What?
I don't know. It could be an A.
Yeah, I think what? I can't hear. I didn't hear you.
He thinks it's a B.
I think it's a B. I don't remember. It won't hold up in the court of law, okay? Right, we can...
But you think mine is exactly not the same.
What are we getting?
You are easier to remember. You are most important to me.
But now I feel I want you not exactly.
You want to be less important, like you do.
No, I want to die.
Are we getting exact marks today?
Maybe.
For 1.5.
504.
Can we start now, guys? I'm waiting here for you. Right, so that boss isn't going anywhere. You can defeat him later. Maths now.
Is it a double?
Yeah, it's a double.
No.
It's a double.
No, it's 1 hour. The timetable says 1 hour.
It's a double.
How do you
Double, then a break, then
Then there is 1 visit.
and then math.
So this is
No, this is math.
And then physics, and then
I got 6.
and then 3 we have chemistry.
3 hours of chemistry?
1 hour of chemistry. At 3.
That's better than 3 hours of chemistry at 1, I think. Important not to mix those numbers up. Right. Last time we were looking at types of mappings. 1-to-1, 1-to-many, many-to-one, and many-to-many. And their graphs, and other definitions like range, and what else do we have? Onto. Yeah. Yes, remember all this? So just to warm up, give me an example of a 1-to-1 function.
X equals Y.
The lamest 1-to-1 function of all, but
No,
true.
that's wrong.
Huh?
Minus x squared is 4. And x squared is 4. So that's not 1-to-1.
Didn't you just say y equals minus x as your example?
No, I said Y equals X. So the third question, and you fell for it.
I don't know what you're saying, please. Can we continue? Right, so... Probably have to plug the cable in. It will be helpful for the projecting of the image. What? Okay. Did you just say woof? Odd or even functions. Okay. Great. Now, you may, not always, not everyone, but some people I'm sure know what odd and even means when we talk about numbers. Does anybody know what an odd number is?
1, 3, 5.
And an even number?
2, 4, 6.
2, 4, 6. But we can have odd and even functions. I don't know if anybody's heard of this before. Anybody? You have? What's an odd function then?
Don't really remember.
Alright, let me make my question very clear. Does anyone know currently what an odd or an even function is? No problem.
Tell me what's an even function, I'll tell you what's an odd function.
It doesn't work like that.
Give and take, Mr. Stephen.
Right. Now, an even function is a function so that if x is in the domain, we have f of x is the same as f of minus x. That the sign is not going to affect the answer. So a very obvious example of an even function is x squared, because obviously using x or minus x doesn't change the answer. So what do you think an odd function would be then?
When you change the sign, you change the y.
Change it how?
Reflected.
Yeah, but give me a algebraic answer.
A negative x gives a negative fx.
More or less. That a negative x would flip the sign. So f of minus x equals minus f of x. So an example of this one, where putting in a minus only changes the sign, but not the number value.
F equals x.
Yes, let's make it a bit more interesting. X cubed. So maybe you can see why they're called even and odd functions, because if you look at the powers, even function x squared, odd function x cubed. But here's some other examples of even and odd functions. So another example of an even function would be, let me think, cos x is an even function. An example of an odd function is sine x. What else could we have that's interesting? Oh yeah, here's one. An example of an even function is the absolute value of x. Have we done this function? Not really, but that's one example.
The absolute value.
What's that?
The
It is
graph of
interesting.
the absolute
Oh yes, and we'll do that.
Yeah.
An odd function, cube root x. Anyways, are all functions even or odd? No, because you can have functions which are neither.
Or both.
No, no, you can't have both, I'm afraid. You can have even, odd, or neither. So, an example, this is not even nor odd. And an example of such a function would be, say, most of them. Ex would be one good example. Yeah, but you can't put minus x into it, so we'll need something else.
What? So, if you put minus x, doesn't change?
For what?
For the ex.
If you put minus in here,
Yeah.
you get a different number. The even and odd functions are functions that only change the sign on the y when you change the sign of the x, but they keep the same number value. Can I continue?
dx and
I'm trying to think of another one. Oh yeah, the quadratic.
Could you explain all that again? I didn't get
Well, I'm going to draw some graphs to help explain. I think a graph will help visualize it.
no, but like
You put the minus in,
yeah.
and it only changes the signs, the answer, the sign of the answer.
So how is x cubed?
Because if you put a minus in x cubed, you get a minus answer. Come in. Now, wait. Come back at 10 o'clock. You're too late, and this breaks my heart. So come back at 10, and don't be late for this one. Go get a frappuccino. Right. What was I saying? Oh yeah. So look, I'll do some more examples. Can I scroll down?
Yeah.
Yep. Okay. So this is what an even function looks like on a graph. Or does anyone want to have a guess or tell me what they think an even function looks like?
It's symmetrical, that's why.
Yeah, it has a nice symmetry here, left and right. So it's symmetrical through the y-axis. But what about an odd function? We'll do that one next.
No symmetry.
Yeah, but there is still something about it. It does have a particular.
It's in the negative.
No.
Yeah, well, no, yeah. One half would be in the negative and the other half would be in the positive. So it kind of, whatever shape it is up here. Oh, why did I make it hard? The shapes in the opposite corners, quadrants, are the same. And also important for an odd function is that it passes through the origin. Because remember, for an odd function, Yahya, if you have x, then you get f of x. But if you put in minus x, the same number but with a minus, the only difference is the sign is flipped around. But it's still actually the same number value, just an opposite sign. So for odd graphs, they have to sort of go this diagonally through the origin. Got that? Yep. Okay, scrolling down. So how can you check if a function is even or odd? Well, if a function is even, we said we should have this. And if a function is odd, then we should have this. And this is just the way to check.
That means they have the same value, right?
Yes.
Like minus the minus. Oh, okay. No.
Great. I like these questions where I don't have to answer anything. Right, example. Let's check some functions if they're even or odd. So let's take a simple one first, x squared. So the way to check is you see what happens when you put minus x in. So f of minus x equals minus x squared, which equals x squared, which equals f of x. So f of minus x equals f of x, so this is even. Right, let's have another one. F of x equals x cubed. Let's check. F of minus x equals minus x cubed, which equals minus 1 cubed, x cubed, which equals minus 1 x cubed, which is just minus x cubed, which is minus f of x. So this one is odd. Let's do something a little bit harder. Let's say f of x equals e x minus x squared. So f of minus x equals e minus x squared.
This is a neither.
No, we'll see. This is e minus x squared, which equals f of x, which is an even. What's the problem? Apart from being in my class, what's the problem? What? I said ex. This is ex squared. Ex and ex squared are different. This is true. In fact, the graph of e minus x squared looks like this, if you're wondering.
Same. What? Really?
It is true.
And ax cubed?
E to the x cubed or e to the minus x cubed?
This is x squared or minus x squared?
Minus x squared.
Minus x squared, then x squared.
E to the minus x squared.
And how would e x squared look like?
Ex squared?
Yeah.
I'll just put on the same graph, okay?
Yeah, sure.
Let's think. See, what's happening right now is he doesn't believe me. But perhaps if I graph it in the program.
No, I believe you, but
But I have my doubts.
no, it's ex is squared, then suddenly I'm not getting why it's turning to a parabola. That's why and
Which-
does it continue going up or does it flatten out? Because it
Not rapidly increase. E to the x squared
Yeah.
rapidly increases.
Then why does the minus x even out? Isn't the negative sign before the x
Correct?
only reflects?
The minus is in front of the x squared. You are thinking of this.
Yeah.
This is different to this.
Yes. Okay.
Is it? Is it?
Yeah, it is.
Great.
Could you scroll up a bit?
I'll give you one to try. Please select the difficulty level.
No.
Max! Alright. This is the most difficult one that I've seen in the exam on this topic.
So we're supposed to work out if it's odd or even, or neither.
Or neither. Yep. And my hint is you will need a graph. Mm-hmm. Me gusta.
I don't have my old book. The rules for these like sine graphs.
You said that sign is odd.
Did I teach you in semester one? I
Sorry.
did, didn't I?
Yeah.
And I showed you how I like to draw the graphs by using a table. Yeah, but
Yes.
no, you're not learning. I need you to learn. We said EX is neither. But when we looked at the graph ex squared, e minus x squared, it was even.
Even, yeah.
So just because I told you sine x is odd, does not make this one odd.
Yeah, but
For example, x squared is even, x squared plus x plus 1 is neither.
x squared plus x
Plus 1.
is neither.
Yeah. For those people who don't want maximum difficulty to begin with, here's an easier one if you prefer. Whoa. Fx equals x squared plus x plus 1. I'll call this difficult medium, and this one will be hard. There is no easy option in math class.
Where does the sine graph start from? 0, like on the x-axis, 0, and then...
0 to 2 pi minus 1 to 1. Oops. The heck?
Can you see this one? Is it the right one?
I don't know because I haven't done it yet.
Because scale factor of 2, so this would be 3 because it's plus 1. So
Could be. But I want a table for it. You know what I like, you know a table. Remember how I showed you how to do these? You don't remember.
Because I never liked it. But I don't save it in my memory.
So you will forget me once you're gone.
It's
What is
difficult.
no, it's quite difficult. Have you committed to an answer? Even, odd, or neither?
Oh.
Yusuf?
Still thinking.
If we change the value of x, then like a positive x and a negative x should give us the same y. That's the even.
Yeah.
Yeah, I think it's odd.
Let's have a look.
I think it's even.
Anyone want to say neither in case it's that? Remember, there might be a fourth option that could be tricking you. Either. It's your choice. It could be either of the two. Right. To make this graph here, we have start, end, min, max, 0, 2 pi, minus 1 to 1. The 2 here just makes this minus 2 to 2. Nothing happens here. The minus pi over 2 moves it to the right. So now it starts at pi over 2 and 5 pi over 2. Nothing changes here. And the 1 at the end just adds 1 to that.
Yeah, that's fine. Yeah. Yes, that's the right one.
So here is pi over 2, pi over 2, pi, 1.5 pi, 2 pi, 2.5 pi. One, two, three, 1. We put our box in. Our box goes from minus 1 to 3 and pi over 2 to 5 pi over 2. We need to split this up into 4 pieces. So the graph for sine looks like this. But of course it continues here. So if I copy this box 1, 2, 3, 4. 1, 2, 3, 4.
So it's even.
Hold on. 1, 2. Copy. So. There's the y-axis. There's the x-axis. And the answer is even. Go, Yusuf!
that's what I had to do. And I didn't even write anything. That's like not proper writing. I just drew it so that I could see.
Okay, don't show off too much now. Just tone it down a bit. Now, that was the hardest exam question I saw for even and odd. But let's look at something a little bit easier, like this quadratic here, yeah? Oh, no, I'm not going down, don't worry. So here's the second example. Yes.
The translation of the x was more than pi over 2.
Then it would be neither, likely.
Not odd.
Well, it depends on how much of a translation of the x.
Pi over 4. So that it's not symmetrical at the y-axis.
Pi over 4? Pi over 4 might make it odd. Here, let's check this one. So what's f of minus x? That would be minus x squared plus minus x plus 1, which would be x squared minus x plus 1, which cannot be fx, clearly. But it's also not minus f of x, because minus f of x would just be minus minus minus. So this is an example of neither, yeah. Yeah? Can I... Okay.
Again, can you just go through what you did here?
Which one?
The last one.
I just put minus x in,
Yeah.
and I ended up with x squared minus x plus 1. This is definitely not f of x,
Okay.
and neither can it be minus f of x. Maybe to be a bit more precise, if you want, you can say this is neither positive or negative f of x. So it's neither even nor odd. Can I? No.
Oh.
Okay. Now let me give you something to try here. Come on, let's go down. Right, let's just say Ex is an even function. And let's just say Ox is an odd function. I want you to work out if the following are even, odd, or neither. Oh wait, I got one.
Is it the same
Doesn't
thing?
it depend on the function?
Is it the same thing as the 1 plus 3?
1 plus 3?
No.
I'm not sure.
What happens when you multiply two graphs together? So the shape of the graph.
No. You don't know what the graphs are. You don't know what the functions are. I just tell you they're even and odd. So just check the way I showed you how to check. See what happens when you use minus x.
2 evens keeps it even. Even and odd makes it odd.
But you're going off of numbers.
No, signs only.
Prove it.
E minus x times E minus x equals Ex.
Yes, so right, it says
No, is it right what I'm saying?
E minus x equals Ex, Ex. So it's even. Oh, I'll give you one more part. Now what's happened?
I have the answer for F, but I don't have the answer for B.
You have the answer for F,
Yeah,
but you don't have the answer for B. That's ridiculous. How on earth do you...
possible?
I just can't understand how you have the answer for F, but not for B.
Because F is more like understandable.
Then B? Oh, Yusuf, I don't understand you sometimes. Right, shall we have a look at these now? So, what did we say for the first one?
Even.
Even, correct. Because if you put in minus x, e of minus x is ex, and e of minus x is ex, so it's still the same, so it's even. If you put minus in here,
How is e of minus x? Isn't it supposed to be x squared?
oh, my heart is breaking. Why is it x squared?
Because you said an even function is x squared.
No, I didn't. That's not so. Not what I said.
X squared is an even function.
Yeah, x squared.
Is an even function. An example.
Don't we have to substitute it as...
Oh, dude, don't break my heart. You're killing me here. Killing me. Look what I wrote. These were examples.
Oh.
So f of x, if it's the same as f of minus x, we say it's even. So the thing about an even function is that it's the value is the same even if we put in a minus, like x squared, but not only x squared. Here, if I put a minus here and here, what happens?
No.
That's a positive, yes, that doesn't change. And what happens here?
Negative.
Negative. So there's a minus here, so it's
Odd.
odd. So this one is even, this one is odd.
A and T are even, and the rest are.
This one is even, because when minuses go in here, they come out here, but two minuses, the plus, so this is even. This one
Odd.
will be odd, this one
Odd.
will be odd, and this one here will be zero.
Yeah.
Why?
Because they will cancel out.
Yes.
Why?
One will be in the
One is
negative, one will be in
other
the
is
positive.
negative. One is positive, the other is negative.
What will be positive and what will
0 to 1.
What will be positive?
One should be positive. 0 to 1 would be positive.
No, I know 0 to 1 is positive and 0 to minus 1 is negative, because positive numbers are bigger than 0
Yeah.
and negative are less than 0.
Yeah.
I want to know, when you say 1 will be positive, what will be positive? What thing will be positive?
EX or X would be
Yeah,
positive.
both of them.
And
From
then
0 to
minus.
1 would be.
So EX, OX will be positive when
One is
when
there's one.
there's 1, when X is positive, yeah. So when you put in 1, you get a positive.
Yeah.
When you put 1 into what? EX, OX. Yeah, but you don't do that because you need to integrate it first before you put 1 in.
Yeah.
So you need to integrate EX, OX. So what do you get when you integrate EX, OX?
EX,
Doesn't matter.
OX.
It
squared
does.
over
For example,
2T.
what? Now think about this. Listen really carefully. X squared is
Even.
agreed.
Yeah.
And you integrate x squared, you get integrate
2x over
Integrate.
Active
2x cubed.
Integrate.
Active ocean.
Thank you. X cubed over 3,
Over 3.
Yes, integration.
Yes.
which is.
Nine.
So integration does matter.
Yeah, but
But the final answer is what he said.
yes,
But for the wrong reason, which means no marks.
They did the final one.
But the wrong reason means no marks.
I still believe it doesn't matter.
We didn't say proof.
Now
We
it's
calculated.
proven that
We
it
gave
doesn't
you the
matter.
calculation.
Yeah, but if it was an exam and you just magically arrived at the answer, you don't get any marks. There's no magic in maths, okay?
So all sorcery.
Or witchcraft.
You better in the school.
Do we have a good reason why this is 0? It is 0. That is true.
Yeah, but both of them are opposites to each other, even if you integrate. So the signs are different, yeah, no matter what.
I'll put you out of your misery. You all have the right idea, but you're not articulating yourselves well. The EX times OX is an odd function, and odd functions have graphs like this. Now, we don't actually know what the function is, neither do we know what it integrates to, because we don't know what the function is. But we know from the graph, this will be the same as this,
Yes.
and this will be positive and this will be negative.
That's why it's a 0.
And that's why it's 0, because this area will cancel this area from -1 to 1 then. So, yeah. If I saw this graph with your answer, then you'd get full marks. Yeah.
Can we just substitute numbers to like find out whether a function is even or odd? Like if we added 2 and 2 is 4 and 0.
Were you not listening to my anger at the two of them with when they were suggesting doing the same thing?
No.
You weren't, okay, you blocked it out.
Wait. If we...
No, please don't ask what you just asked, because
No. If we integrate
Yes,
an x cube,
yeah,
which is odd,
yes,
we'll get an even function.
yes,
This is an odd function, right?
yes.
So if we integrate it, we'll get an even function.
That's another logical way to think about it.
So is this the graph of an even function?
This is the graph of an odd function.
Yes. So why didn't we draw the graph of an even function, since it's
Because-
even after the integration?
Oh! Integration of fx dx means the area
of the graph. Yes.
of fx, not the integration of fx.
Yes.
Yeah, so what is this?
This is odd.
And what graph is this?
Odd, obviously.
So what are you asking me?
There's no graph for the integration.
Exactly, there is no graph for the integration function. I think you just like are sitting there going, how can I wind Stephen up?
Still moment.
Yeah, I know, it's a long day. Still a lot of day to go. Right. Let's have a look at what questions I gave you. Oh yeah, here, Faisal, I only opened this program just to keep you happy. The graphing program. Right. E power minus x squared.
Can't we draw two graphs at the same time?
Yes, I can.
Yeah.
Now, did you hear that disappointment in his voice that I was right? You can really hear it, can't you?
It's like what's it called? And the cube.
I didn't draw the cubed,
Yeah.
but you want to see it.
Yeah.
I think it will look a lot like just EX, except maybe more stretched. I don't know, it's a bit flat around the centre.
No, wait.
It goes though.
You might not be able to see it, Faisal. What I'll do is I'll just redraw it fresh. There it is.
Ugly.
It is pretty ugly, isn't
It's
it?
not like the square. This is because of the, isn't that an inflection?
At the center?
Yeah.
Yes, it's an
It's
inflection because it goes from concave to convex.
Yeah.
And it's also a turning point as well.
Yeah. How about negative Q?
Right, right. E to the minus x cubed.
Yeah.
This should be in something.
See, it just changes the direction of it.
Yeah.
Because it's an
Any other functions while I'm at it? No?
So the e power minus x squared is a bell shape. The thingy improbability that has a bell shape.
Normal distribution.
Normal distribution, yeah. Yeah, normal distribution.
But you knew that deep down. You just forgot.
Yes. Yeah, I studied it. With a nice big graph. Not graph, table.
And we'll do that at the end of the semester.
Yeah, I know. But it's nice, I like it.
It is a good topic. Okay, any other graphs you want to see? What?
No.
What graph do you want to see? What about 1 over x squared, even or odd?
1 over x squared.
1 over x squared, even or odd?
Even.
Correct.
The graph of 1 is 1 over x squared.
1 over x squared is an even function, and that's the graph of it.
Yes. But 1 over x is odd?
Yes, and actually this is interesting because I said odd functions must pass through the origin, which is true, provided of course that the graph has a value at the origin. And this is actually an interesting one because this is an odd function, I believe. Yeah, it is, because if you put in minus x, yeah. But the graph doesn't pass through the origin, but it is still the same in opposite corners. But it doesn't pass through the origin. And the reason it doesn't pass through the origin is because it's not defined at the origin. If the function is defined at the origin, then it must pass through the origin. No, that's not true either. Just because it has a value at the origin doesn't mean it has to pass through the origin. And it can still be an odd function.
Yeah. Y equals x plus 2.
That's not either.
That's neither?
Yeah. I will give you that as a question to do before we finish this. I want an odd function. So I want you to give me an example of a function that's number 1, odd.
Where's Andrew? Did you see Andrew? Did you see him at home?
Probably staying. No, he lives in the back court.
Correction, I have to notify a correction. Earlier in the class I said an odd function must pass through the origin. This is not true. You can actually have a situation where it has a value at the origin and it's not 0.
It's still odd.
And it's still odd. I'll give you a minute and see if you can give me an example of such a function. Needs to be odd, has a value for f0, but that is not 0.
Sine graph.
What's sine 0?
What?
What is sine of 0?
No, sine
Sine
0. I'm saying any, like, you need to have a coefficient beside the x. Then sine x.
That 0 would make
Sine x, S-I-N,
Yeah.
this is an odd function. With a coefficient beside the x,
Yeah, it would still be.
but it'll still be 0.
Sine 3x.
Is that what you mean, like sine 3x, yeah?
Still
Yeah.
0.
Yeah. Sine 0 is still 0.
Because you multiply the coefficient with the 0.
about a cubit.
0 cubed?
No, a cubit, like a quadratic cubit.
Yeah, give me an example, like write down a function.
It's not possible.
It must be possible because I must have an answer in my head.
Log x.
Well, we don't know the graph.
Log 0
You're
is 1.
getting closer. You're getting close to an answer, but log of minus x is not defined.
E power x.
That's neither even nor odd. I said it needs to be odd.
1 over log x. Or minus 1 over log x.
That's the same thing, really. One over log x. Still, that's not defined for negative x, though.
Yeah, if you have a minus beside it. Minus
No.
1 over log x.
It has to go on the negative side of the y, like below.
Because it's odd.
Yeah.
Shall I put you out of your misery?
Log x squared.
Now you're getting close, Yusuf, to a possible answer, but let's just examine that one. You said fx equals log x squared. So that graph here would look like this, but the only problem is it's even, and it doesn't have a value at 0.
Log x to the power of minus 2.
No,
Still doesn't have a value at 0.
it has to be plus or minus something.
How?
But if it is plus or
Because
minus,
0 minus 2 is undefined.
Log
No, log 0 is 1.
No, it's not. Log 0 is undefined.
log 1 over x.
Log 1 over x.
that's
No.
an interesting graph.
This is quite. No, not this. Alright, shall I
It's
tell
a log.
No. But I just like your thinking.
What
Yeah.
sort of function is it?
The mathematical one.
No, I mean linear, quadratic, cubic,
None of the above.
damn.
Right.
Did we study it?
So I have two examples. One which you can figure out because it doesn't need anything special, and then there's a special one. So let me give you the non-special one first. Huh?
Done?
No. This function, 1 over x, when x is not 0, and 1 when x is 0. So this function is odd because when you put in minus x, you get minus f of x. But when you put in 1, you get, when you put in 0, you get 1. So in other words, the graph looks like this.
What?
The graph looks like this. When x is not 0, when x is positive, you get this. When x is not 0 and negative, you get this. This makes it odd.
Yeah.
When x is 0, you have this value.
1.
Yeah.
And minus.
No.
Minus 1.
What's f of 0? 1, according to this formula. What's f of minus x? Minus f of x. And this is still true for 0. Because what's f of minus 0? That's the same as f of 0, which is
1.
1. Well, no, it's not true for 0.
Yeah.
But we're not supposed to check for 0 anyway. Just for x and minus x.
The point you draw on the graph,
Yeah.
what is this?
The value when x is 0.
Yeah, when you put 0, you get no value. When
Yeah,
x
so
is
I forced it to have a value of 1 when x is 0.
How do you force it to have a value?
Because it's my function, I can have it do whatever I want. I call it the s function.
I'm still not getting it. What's the... If it's a function,
Yeah?
it's an equation,
No.
no?
No.
So which one is the function?
Huh?
Which one is the function?
This is the function.
And it has like special.
Conditions.
Yeah.
You didn't say we can create our own function.
I said, give me a function.
You didn't say create.
I have no idea what that sentence means. How else are you supposed to make a function? Get someone to give it to you. If you're not going to create it yourself. Here's another function which you might prefer. This function, sine x. So for a moment I thought you were giving me the right answer. Then I realised, oh, he means the other side. So sine x is a simple function. It has the value of 1 when x is positive. It has the value of 0 when x is 0. And has the value of minus 1 when x is negative.
But doesn't this pass through the origin?
It does actually, so I
It
could
doesn't pass
I could call it sine 2 function and give it a
Zero, yeah.
give it a different value. Yeah, we'll say 0.1 or something.
Yeah.
Yeah, math is fun. Right, let's have a look at the worksheet. That's definitely not on the exam.
What is this though? What's it called?
The sine function.
Yeah, what?
It gives you plus 1 if it's
Trigonometry, exponential.
functions.
That's calculator.
Is it on the calculator?
What's the graph of it?
What's the graph of it? Good. So what's the graph of the sine function? Anyone want to try and guess it?
Something, and then not 0, and then something. Similar to the thing on the,
I think it's really close to.
Really?
Yes.
That's it?
That's makes sense.
Yeah. When x is positive, you get the value of 1. When x is negative, you get the value of minus 1. And when x is 0, you get...
I was thinking of absolute values.
Yes. Yeah. Alright, that's enough
But
that's enough messing about. Yes?
if we draw a graph of an absolute value,
We haven't done that yet, but it looks like this.
yeah, I know, but it's not going to the side, so it's not odd, it's even.
Correct.
Yeah. Can't we make an odd one with an absolute? Because like if it's an absolute for the x, it's
No, you
symmetrical
can't, you
on the
can't,
y.
you can't,
If
you
it's
can't.
absolute for the y, it's symmetrical on the
Just
x.
use an absolute, you can't.
Yeah.
You can't. It has to be even, or could be neither. Don't think we can make it... actually...
It is odd. Oh no, it's not odd, it's even, sorry, yeah, it's even.
Can you make it odd though? Absolute x by itself, you can't. But if you have something else inside the absolute,
Function.
like a function, you might be able to.
If like what I was thinking, if we make it the absolute for the y, so that it's symmetrical on the the
Okay.
x-axis, but then we say that it's reflecting when the x is. You get? Can I?
No.
I'll draw it.
No, don't. Leave me
No,
alone.
please. It's something like this, but we.
But that's not odd.
Yeah, we give the function
Yeah.
thingy where that if it's over here.
It has that value, and then the other side has another one. Yeah.
This works,
Uh,
so that the graph is.
but it's not a function because it's not a function because that first one you drew
Yeah.
is not a function because that is one to many.
So this doesn't work.
Because it's not a function.
Okay, how about if it's something like this, and then we say that negative x is negative y.
Then it's not really absolute anymore. All right. I want you to try these for a couple of minutes, and then the next one. Next one is okay. Right.